Alright, so we are here to study statistics. Statistics is the set of math tools that we use to organize, summarize, and interpret information. Okay, so these statistical tools, these statistical procedures, are used to measure something about a group of units. Okay, so these units, maybe I'll write the whole the whole group of units that we're going to study. This is called the population. Okay, and then the thing that we're going to measure in the population is called the parameter. So the value, usually this value is numerical, but not always. The value we are measuring this is called the parameter. Okay, and it's often the case that we are unable to measure the whole thing or capture this information about the whole group, and so we measure something from the smaller group. And so if we took a subset of the population, so a smaller portion of the population, this is called the sample. Okay, now again, if we measure something about the sample, this is called a statistic. So the value measured from the sample, this is called a statistic. Okay, not to be confused with statistics as a concept, which is the the package of tools used to study the population. So it's kind of helpful if you think about it. Population, parameter, and sample, statistic. So the P and the P and the S and the S. Okay. The thing or the characteristic that we're trying to capture, often if it's a numerical value, and if it's a value that can change. So if we ever had a varying value that represented something about our population, this is known as a variable. Okay, so this variable is a characteristic which can change. So it's a changing characteristic. Okay, and when we are measuring this variable, so when we measure a variable, okay, we are collecting data. So if you have a bunch of data put together, and keep in mind that data is plural, if you have a bunch of data kind of organized together, we call that a data set. Okay, and the data set, the values in the data set are the values that we're going to apply these statistical procedures to. Okay, so when we have a data set and we are looking to describe this data set, when we're looking to organize, summarize, or simplify this data set, we're going to apply descriptive statistics. So we have two kind of classifications for statistical tools. The first, descriptive statistics. Okay, and when we deal with descriptive statistics, we are trying to summarize something about the data, we're trying to organize the data, okay, or we're trying to simplify the data. Alright, often when we have sample data, we are going to be measuring, for example, the average age the people in the sample, or we're trying to capture the overarching ratio of male to female students in an elementary school or something. These are examples of descriptive statistics. We're trying to get a snapshot that represents the greater picture. We're trying to get kind of a representation of the sample. Okay. The other category of statistical tools would be inferential statistics. Okay, and now inferential statistics are used to make to draw an inference about the population, but to take something from the sample. Okay, so we draw an inference from the sample to make a generalization about the population. Okay, and we'll talk about inferential statistics a little bit later on. We're going to start our discussion in the first couple of chapters with descriptive statistics, kind of dealing with how would we measure kind of the center of a data set, or how would we measure the kind of overall span of a data set, the values in the data set, and we're going to build up to this idea of how would we take a small set of data and make a generalization about the population. Okay, so something to keep in mind when we're dealing with inferential statistics. If, for example, we were trying to measure something about the population, so we have maybe this idea of the population as a whole. It's just this box, right? So this is representing our population, and within this population we collect some data, and this is our parameter. Okay, so this population maybe is the set of all American citizens, and we're trying to capture the average age of American citizens. Well, that's going to be kind of difficult to do, and so what we can do is we can collect a sample. But let's take this little oval as our sample. Okay, within this sample, notice it doesn't represent the whole population, but it represents this part of it. Now the sample might come from over here, might come from over here, might come from right here. It doesn't have to come from any particular area. I mean, our goal is always to get a representative sample, but it doesn't always happen. And so when we have this sample, the sample has a statistic, which is the average age of the units in the sample, and notice that the statistic differs from the parameter. Okay, so that naturally occurring difference, the naturally occurring difference between the statistic and parameter is known as the sampling error. So sampling error, I mean, it always happens. Our job, and when we get to the inferential statistics part, our job will be to minimize sampling error. Okay, so let's take a look at some examples of kind of playing around with the idea of a population and parameter and sample and statistics. So here's our example. Okay, we want to look at the ratio of female to male elementary students. Okay, so here our population would be all elementary students, let's say, in the country. Okay, because other countries don't call them elementary schools. And then our parameter, the thing that we're trying to measure, is this female-male ratio. Okay, so I'll write it like this: females to males. Okay, now it won't always be possible. I mean, maybe we publish this information and it's possible to capture every possible elementary student in the U.S. But if we don't have that, we might look at maybe one school. Okay, so we took one elementary school. This would be a sample. And then within this one elementary school, we might look at the female to male ratio of this one elementary school. And this would be the statistic. All right.